For example, we have the Spanish blackout a few weeks ago, and that was because we don't have grid-forming inverters. We have just grid-following inverters.
Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today, our special guest is Ignacio Carellan. And Ignacio is in my heat spring class, and he also has a company called Inverter Advisor. And he is talking to us all the way, 1/3 of the way around the world in Spain. Welcome to the show, Ignacio.
Hello, Sam. Thank you very much for this podcast proposal. I'm Ignacio Carellan. I run Inverter Advisor. Basically, I help big solar projects avoid inverter failures. I spend a lot of time in the field and in factories making sure things don't go wrong later. So making system more reliable is what I focus on.
Yeah, I know. It sounded pretty neat. So you can advise people on inverters from the name of your business, I'm assuming.
Yeah, that's basically what I do. I created this company to support big companies with large-scale solar projects to reduce errors and to reduce problems in the solar plants and increase reliability as much as possible.
So do you know like what are the good inverters and what are the bad ones or not so good ones? Are they all good?
I mean, I don't know everything. I can evaluate if the inverters are the right inverters for the location. Because let's say all inverters will be good for some specific conditions.
Is there any inverters that you just totally hate? Or maybe you don't want to say?
I mean, it's not either one. It's something that I like more than others, let's say.
Okay. All right. Yep. And so as many people know, what an inverter does, at least according to the National Electrical Code definition, is it converts DC to AC, direct current to alternating current. However, if you have an inverter with a battery, it's got to do both. It's got to also go AC to DC, which isn't really the definition of an inverter, but everybody I know still calls it an inverter. And there's lots of different inverters, and it's getting to be super, super important to know how to operate them and how their software works and how to connect them together and how to design them with different maximum power points and things like that. Are you usually working with a certain size of inverter, like big or small, or all of them?
I normally work with utility scale inverters. So it's, in general, they're going to be starting from 250 kilowatts. And they will be going up to 4.6 megawatts, which are the more new inverters from some of the manufacturers. So all of them utility scale.
Great. So once again, I think you said, was that 250 kilowatts? So that's 1/4 of a megawatt to 4.6 megawatt inverters.
Yeah, you're right.
Okay, so
those will be central inverters, which are big inverters. Normally they will be modular, so they will have different power stacks that you can change them. And then the other ones will be string inverters or multi-string inverters.
Great. And then also, are you working mostly with solar alone or solar with batteries, or some solar alone, some batteries alone, and both together?
I can work with everything, but I'm more focused in just the inverter itself. So I can work with any situation. But in general, the most of the projects I have worked with are related with solar, and a few of them also with batteries. But only batteries is something that I haven't worked yet.
Okay. And are you mostly working on projects in Europe?
No. In fact, I work more outside of Europe than in Europe.
Oh, that's funny.
I work globally, like in the States. In fact, most of my clients are from the US, but they want me to operate in Europe, for example.
Great.
And then my clients in Europe, they want me to operate in another countries. And also I have clients from Australia, South Africa, and other parts of the world.
Great. And so that's why you're getting that NABCEP certification, because you're also probably a lot of it has to do with working in the United States, but also it helps working in any country too. I have people from all over the world taking my classes, getting their NABCEP certifications. So it's always a good thing to do. You wouldn't by any chance know of a guy in Spain named Ryan Jones? Have you ever worked with him?
No, I haven't.
I studied for my NABCEP certification with him, like many years ago, I don't know, like 18 years ago or something like that. And we were studying together, and he got a job for Solyndra in Spain, and he is in Spain still. So I've seen him grow up in Spain. We were a lot younger back then. And I ran into him just a few different times at the Intersolar conference, also known as the Smarter E. So it was kind of neat.
I don't know him, but probably this is a good opportunity to try to find him and make a good connection.
Yeah, I'll introduce you. But I don't think he's doing Solyndra anymore. But that was kind of funny. That's what brought him over there. Those really cool, if you call them solar modules or solar panels, that were just these tubes that had thin film on them. And you put them on top of a roof, and the old timers know what Solyndra is. And a lot of people don't know what it is anymore, but it was pretty cool.
Okay, yeah.
And so do you see any kind of trends happening from your work as far as for utility scale, which you're only working on utility scale, when you talk about string inverter versus central inverter?
I'm seeing that it's a lot of case dependent. I see some of my clients would prefer a string inverter in Europe, but on the other hand, in the United States, it's more about central inverters. And the trend is in central inverters is to make like more powerful inverters with the same side inverters. They are trying to increase reliability and also to increase different protection systems. Also potentially increasing the MPPT range, but that would be, I would say, that the most important trends at the moment. And obviously hybrid inverters that can work now with batteries. And in Spain, for example, in Australia, also in USA, there is an important topic from my point of view, which is the concept of grid forming inverters. Mm-hmm. So are those inverters that can really generate a grid and maintain the grid. For example, we have the Spanish blackout a few weeks ago, and that was because we don't have grid forming inverters. We have just grid following inverters. So that means once the grid is gone, they cannot return back and create a grid. So that's a topic that I saw quite interested in the last Intersolar, and I think it's something that the whole world of solar should be pushing and informing everyone that that kind of technology exists.
Yeah, great, for sure, yeah. And so there's a lot of different ways to explain the difference between grid forming and grid following inverters. And I think a lot of people don't understand it, so it's probably a good topic to talk about. And so when you have spinning machines, when we say spinning things, we're talking about that archaic type of electricity when they burn things or, make nuclear reactions and spin things. There's all this inertia. So like even, if there's like different things where like you're going to have your voltage drop down a little bit or your frequency change, there's this heavy thing spinning and it gives you inertia. And with a traditional inverter, a grid following inverter, we don't get that inertia. And when solar and storage is a small part of the grid, it doesn't really matter. But as we get to be more and more of a greater part of the grid, it matters more. And so especially in places where they put more solar as a percentage of what's going on in the grid, like Australia you mentioned, it's much more important to have these grid forming inverters. And with grid forming inverters, we can get to 100% solar on the grid for, producing all of our energy, no problem. And a lot of people are saying that we can't do that. And as we get more and more solar on the grid, this is getting to be more and more important. I think one of the problems with grid forming inverters is we don't have the policy to encourage it here in the United States, because it might cost a little bit more, not a whole lot probably. But if you're going to just put some little extra benefit and make a little bit extra software, how that inverter is going to work, it will cost a little bit more to make what they also call synthetic inertia. Do you have a better way of explaining like what a grid forming inverter is?
Not really. I can do it for just a little bit point of view. Will be like a grid forming inverter can generate or can deliver voltage. And once that voltage and that frequency is created, a grid following inverter can just bring current into the grid. Mm-hmm. So that's the main difference. One will be considered as a voltage generator, another one will be considered as a current generator. But at the end of the day, they are quite similar. I mean, they are exactly the same machines with just an inductance in the AC side, and that's it. It's not that different, to be honest.
But I guess they have to, like, when they're in the factory, they have to make them a little bit differently just to make them do different things. And I would almost call a grid forming inverter, it has lots of similarities to a standalone inverter, like, so an off-grid inverter. But it's not an off-grid inverter, but it's more that way, I guess you could say. And then I think another thing too, that with our society, we always try to get black and white and just go like, this is this way and that's that way. And of course, there's in-betweens. You could have like different characteristics of both.
I agree. Definitely, the standalone inverter will generate both the voltage and the current. In terms of the design of the equipment, one hand will be the software. There will be two different software that will be required. And on the other hand, in terms of the hardware, there is not that much difference. In general, I mean, manufacturers will never tell you 100% what they have changed. But in general, it's just a couple of PCBs and inductance in the AC side.
Can you explain that a little bit better? So the difference, like this helps me learn too. So the difference inside of a grid forming inverter is there's just a little bit of hardware that's different. And you said
A PCB, printed circuit board. A printed circuit board. I mean, I'm just talking about like a little electronics. You're going to have slightly different electronics and slightly different active. Does it make sense from that point of view?
Great. And so like, let's say that you have a megawatt, like per megawatt, how much more does it cost to make a grid forming inverter? Just like, you don't have to be exact or like on an order of magnitude or just a little bit more or,
To be honest, I don't know. I haven't worked with any project so far with that, but I assume that it shouldn't be more than like 5% maximum. I don't think there's a much different from that point of view.
So that was a good answer. Just kind of like an order of magnitude. It's not like doubling the cost. It's not.
No,
it's
I
not
don't
1%.
think so.
Yeah, and I think probably too, if we made all of our inverters grid forming, then the price will go down, and maybe it would just be equivalent.
Yeah, I would say so. I mean, for example, if you are thinking about another type of inverters, like the ones you were mentioning at the beginning, those that can convert both DC to AC, but also DC to DC, those inverters are much more complex than the inverters that will be grid forming. People, when they require those inverters, they're happy to pay that small extra amount of money. So I don't think that is a problem related with price. I think it's a problem related with the requirements for the grid connection. In Australia, for example, it's mandatory these days. The penetration of renewable energies is so high that they need to have this kind of grid forming inverters.
And one thing about grid forming inverters too, we're talking about usually a system with batteries, with energy storage.
Yeah, definitely. In fact, most manufacturers, they say they haven't developed any inverter so far that can be grid forming without batteries, because you need to have a constant DC input to be able to generate that constant output.
Yeah, and I've thought about that before. And so I was thinking like perhaps if you did have a solar inverter and it was clipping, it could probably do some grid following, but otherwise you're usually working at your maximum so that you wouldn't be able to increase your power for a grid event, like to help out the grid.
Yeah, I mean, I don't know if increasing power will be required. Some inverters can work like a 5 or 10% extra at some points of the total maximum power output. But I don't know if it is really necessary to increase that power at some point.
I think, increase the power from the source. So like the battery or like where it's coming from usually. Like if sometimes you need to be able to draw more for the battery to stabilize things on the grid. Like if there's a big demand for power on the grid, like whether it be like a load's turned on or power lines shorting out or, somebody crashing into a power pole, something like that, or another power plant going offline too could cause that, or like the wind slows down and you would need to be able to draw from energy storage.
Yeah, but I would say that, obviously you're gonna need that DC input, you're gonna need that battery to be able to establish the total power output. But the nominal power of the inverter is something that is going to remain constant, and then generally you cannot exceed that power.
Yeah,
in
the
normal
output
operations.
power of the inverter.
Yeah.
Well, great. Yeah, like so probably too, like usually when you have a battery inverter, you're going to not be working at full peak. And then when you need, sometimes the grid will need more, a little bit more, and a battery can help take a little bit extra to help stabilize the grid. So for instance, if the grid frequency goes up, the battery takes from the grid to reduce the frequency. If the grid frequency goes down, the battery will send more power to the grid to stabilize the frequency that way. So
Yeah, that's true. And that's the good thing also for inverters is that they can adjust those things in the following cycle because they don't have that inertia we were talking about before. So that's the good thing of the power electronics. So in terms of having a stable grid, inverters and battery systems are, from my point of view, the best choice to be used.
do you know of people that are using grid forming inverters in the United States?
No, so far I know that they are starting to develop that, but I don't know anyone in the USA. I know the ones that are working in Australia at the moment,
Yeah, okay.
and I know the manufacturers that are developing those kind of projects in Australia.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
So I know that there's this organization that I've watched a lot of their YouTube videos that talks a lot about grid forming inverters, and it's a great place to learn. And I just watched their YouTube channel. We'll put it in the show notes. And it's called the ESIG or Energy Systems Integration Group. And I go on there and I learn about, grid following and grid forming inverters and a lot of other stuff too. And so it's a bunch of smart people. And I believe they are out of Texas, or at least some of their main people are over there in Texas, because they talk a lot about ERCOT, which is the grid over there in Texas. So that's another good place to learn about grid forming inverters. Do you have an opinion why we're not seeing more grid forming inverters in the United States? Like, why don't we have the policy that encourages this? We just don't have enough solar on the grid, maybe?
To be honest, I think that, it's something that hasn't been necessary so far. Probably the grid owners, they are aware of that situation, and probably they're going to have to be changing the policies in the meantime. But it's something that definitely has to be analyzed and try to find solutions, because you cannot keep growing solar power plants without making grid forming inverters mandatory, at least up to 8%.
Yeah, it seems to me too that maybe we just don't have enough renewables on the grid to make it be a huge deal yet. But as we get more and more on the grid, the utilities, I think, are going to be the ones requiring it, that we need to have grid forming inverters. So it's probably a good idea to, for people that are your clients, to start thinking about getting grid forming inverters figured out and dialed in for the future.
Yeah, the problem I see with that is, if that is going to be, as commented, let's say, I don't know, a 5% extra cost, why would they expend that extra money if it's not something that is necessary at the moment?
Yeah.
Because renewables are so high. I don't know exactly which one is the number, but probably above 50%.
No.
So I don't know if at any time at all, any grid in the USA will be operating with 50% of renewable energies at any time of the day.
Yeah, so it would maybe be something like a 5% extra cost for your inverter for something that the utility would not let you use anyway. But maybe
Yeah.
what people should do, though, that are, building systems, designing systems, big utility scale solar systems, is to think about this in the next 10 years. Within the next 10 years, it's probably going to be super important. And it's going to come all at once.
I guess so. Yeah.
And so people should start learning about it.
Yeah, if we continue with this politics of being environmentally friendly and growth renewables, this has to be in the middle of the debate. And we have to find an answer about how it's going to be implemented.
Great, great. So when you're seeing these other countries that are using grid forming inverters, are they all sizes of inverters as far as for utility scale? So between 250 kilowatts and 4.6 megawatts, so a quarter of a megawatt all the way up to, over 4?
The ones I know at the moment, they are working with large scale inverters that are between 4.2 and 4.6 inverters that are delivering, 4.6 already megawatts.
Yeah, big inverters, yeah.
Yeah, quite big inverters, yeah.
Yeah, great. So when you're working with these big inverters, are they like factory built for different countries, or do you see inverters that work in different countries where you could just reprogram them to work in the different countries?
You normally build the inverter for two different type of countries, and it will depend on the frequency of the grid. There will be 50 hertz or 60 hertz. And apart from that, there will be, the building will be pretty much the same. What is going to have to be changed are maybe some extra add-ons depending on the grid conditions and the protection systems. But generally, manufacturing, you can't tell any different in a production line. It would be exactly the same as a power. Only a couple of components might change.
Yeah. Like I remember when I was teaching these solar classes in the Philippines somewhere around 10 years ago, they weren't big inverters, even though I was teaching for the utility, but it was just for the training. And we could go in there and set them for 50 hertz, 60 hertz, different voltages, all that kind of stuff. And
yeah, you will work for any of them. I was just thinking of some of the components, like for example, the LC filter, or maybe the kind of inverters that will have a transformer. In those cases, then you have to adjust slightly some of the components for the specific grid. But again, you will have the same components, but with slightly different specifications.
Great, great. All right. So what do you see as far as important characteristics in inverters for people to look for when they're designing utility scale systems in general and maybe also in the United States?
From my point of view, and the real reason I created Inverter Advisor is the reliability of the inverter. Because at the end of the day, everyone talks about LCOE and performance ratio, but without reliability, none of that matters.
Let's talk about what that is. So levelized cost of electricity, LCOE?
Yeah.
So just for people that don't understand, yeah.
Yeah, so that will be the price of the electricity once you are operating your solar plant, depending on how much money you're going to have to spend, for example, in operational maintenance or repairing any inverters, or maybe because your inverter is not producing for any reason, then the cost of your energy is going to be increased because you're going to have to spend more money in that energy, the generation.
Yeah, yeah. And then also, when you're looking for inverters, like you said, most of your consulting is in the United States. So you have all of these tariffs, right? There's all these, how do you deal with that? It's almost like one day to the next, there's a different tariff.
Yeah, I'm not that expert from the tariff point of view, so I'm more dedicated to the point of view of the manufacturing availability and also operation. But it is true that it will depend on the price of the electricity in the market at that moment of the day. So if you're expecting a lot of demand, then obviously the prices will rise, and also will depend on the availability of other different sources. So that price of the electricity is something that you really need to get very in depth to understand that. And then on top of that, in countries like in Spain or Germany, for example, you have some specific tariffs that will be warranted to your solar production if you can produce a minimum amount of hours per year. And that's a deal that was introduced a few decades ago to push investment in the solar energy. So if you can guarantee that amount of hour produced, then you're going to have a minimum tariff, you're going to have a minimum benefit from solar plant. And then you're going to be competing with others with selling your energy.
So when you're looking at LCOE, levelized cost of electricity or energy, some people say, and you have to kind of figure out like how long do you expect the inverter to last? And some of the inverters will, I guess when they break, you just get a new one. Maybe that would be more common with the 250 kilowatt inverters. And then when you have the big 4.6 megawatt inverters, you probably will be more likely to repair them than replace them. So how long does an inverter last these days? People don't know, they don't have a crystal ball, but you have to put something on the spreadsheet, I guess.
It is very difficult to define that. Some manufacturers will tell you that they can last 25 years, and those inverters are probably able to do that, but it will depend on the environmental conditions, the real conditions, and also how the inverter is operated. The numbers will tell you it's a very broad width band, and it will last between 7 and 13 years, the inverters.
7 to 13 years. Okay, great. Yeah. But people are a lot of times writing down like what the warranty is. And I think sometimes people think that the warranty means how long something's going to last. So hopefully something lasts longer than the warranty. And what happens if it doesn't last as long as the warranty? Then you might have a problem still getting the warranty honored because a number of things could happen. The inverter company could go out of business. The inverter company could have attorneys that say like looking at fine print in the contract for the warranty, and somebody else might own it and just forget that what kind of warranty paperwork there was, or maybe instead of going through the hassle of dealing with a warranty, there's going to be new equipment that's better and less expensive.
Yeah, you're right. Also, inverters manufacturers maybe say it is not their fault and it's your fault because whatever reasons. So yeah, it's very complex then to claim the warranty. Also, many inverters manufacturers, what they try to do is also to be contracted to perform the operation and maintenance of their own inverters, so they can replace now and again different components.
Yeah, and I'm sure too that if there's a warranty that's really expensive and they don't want to mess with it, they can mess with their customer. In fact, I did some consulting for this group in Panama, and I won't say the inverter company's name just to be nice, but it kind of upset me. And so they were using microinverters. They're using a very popular microinverter, and they installed many megawatts of it. They did at one point the largest microinverter system in the world, but that was surpassed since then. And some of their inverters started breaking, and I kind of almost think that perhaps the inverter company said, well, they're in Panama, we're not going to really ruin our reputation and it's going to cost us too much. Let's make a business decision, and we're going to send them on a wild goose chase. And they paid extra money for like the extra warranty and all this kind of stuff. And they just made them, like for every inverter, they wanted them to do so much troubleshooting that it was more than the inverter was worth. It would be like, if they said, okay, for the warranty for this inverter, we're going to keep asking you to do things until it's 2 hours per microinverter, or, something like that. And it would just like throw the thing away. So they actually switched microinverter companies, and they were just like super nice guys. And I felt like it was an injustice that they were just sending them on a wild goose chase.
Yeah, I guess that Panama, that kind of tropical climate, is very hard for one inverter.
Yeah, I mean, I understand the tropical environment, but they had like a whole bunch of the inverters still worked. There was just one batch of them that didn't work. So it was like most of the inverters that they installed worked. And then there was just like a few $1 million worth of inverters, just a small amount of what they did. And then those ones just like failed right away, like a whole bunch of them. And they're just like, hey, we need to get these all replaced. These are bad. And they're like, oh, we're not going to replace them. We're going to give you so much trouble. You're going to just switch brands or something, And it's like, what are you going to do? You're in a different country. You're going to hire some attorneys. We have better attorneys than you.
Yeah, I see what you mean.
And they were like super nice people, and they were doing really good work. And even though they didn't have to, they were following, the latest version of the NEC. They're doing everything really good. So
Yeah, I see. Then, I mean, you're saying then that it was just one batch of the same kind of inverter.
yeah, it was like they used there's different models, and it was just one model.
One model,
Yeah,
but same brand.
same brand and different models.
Yeah.
Because they get better, they get a new model that's better, and
Yeah.
ones for bigger systems too. Instead of they're designed for like 3-phase and stuff like that.
Yeah, the problem related with that is not performing reliability testing because that maybe the second model was designed in the right way, following standards that guide you to prove that your design is the right one, and then it can hold a tropical climate. Maybe it's not related to the tropical climate, but also reliability testing will evaluate if some of your components will degrade faster than others. Because I've seen top manufacturers that will perform a great reliability testing, but then some of the batches are failing, and that is because some of the components haven't gone through reliability testing, and those components may have some materials that are really affected by temperature or other conditions, and then they're going to be failing sooner than expected.
Yeah.
So yeah, that's why I think reliability testing is that important in this business.
Yeah, and I'm sure that company was doing reliability tests, but maybe their reliability test is like, let's have them install these in Panama first and see if they work down there.
Yeah,
But it's interesting.
I've
and
seen that many times.
I should introduce you to them since you're the inverter
Yeah,
advisor.
definitely.
Yeah. So
Yeah, I have audited, not all, but a lot of the key manufacturers in the world, and only few of them do perform a proper reliability testing or have a reliability program for their inverters. And at the end of the day, what they do is what you have said. They want the clients to test inverters in the field. So if the environmental conditions are good for your inverter, then it's that you don't have a problem. But if the environmental conditions are not good for your inverter, we are talking about like a massive amount of money lost. So one of my clients paid $40 million to leave some projects in Australia just because the inverter failing. And those inverters didn't pass properly reliability testing. So I think it's something that owners and operators should care about.
So it sounds like your services are very valuable because they can save people $14 million.
Yeah, that's what I would say. Yeah.
So everybody should give you a call.
Yeah. I mean, not everyone, but because I always say the same. I don't want you to need me, but in case you need this kind of advice, I recommend you to do it. Because also I have performed already 12 root cause analysis in different countries in the world, successfully performed. And obviously from the first one to the last one, I've been learning a lot of things, implementing new testing methods, implementing new ideas, also reading many other root cause analysis from many different companies and learning from them. Yeah, it's a difficult thing to be done, but it's doable. And I think that it's really profitable from the people that really care about reliability.
Great. And so if people want to find you, of course, they go to inverteradvisor.com.
Yeah.
And you can help them save $14 million every time they talk to you. Yeah.
I mean, potentially, I don't think it's going to happen like that. In fact, my client lost much more than that. They lost 100 just because they choose the wrong inverter.
Yeah. And that was before they called you.
Yeah, that was before they called me, obviously. I don't want to get involved. If they call me and that thing happens ever, then I'm going to have to stop working as a consultant in this field.
Yeah. So I think there's a lot of reasons why people should call you. And I think the most important reason is they need to meet you in person, and you're in Spain. So it's a perfect way to go to Spain for a business trip, right? What part of Spain are you in?
Definitely, yeah. I'm placed in Albacete, which is in the middle of Spain, south of Madrid.
Okay, just south of Madrid. I should have came down there just to record this podcast, But I think I'll wait.
Yeah, sure.
We'll have to do another podcast in the winter time because that's when I want to be south of Madrid. Yeah. Not in the
Please do
summertime.
it.
Yeah. Okay.
we
great.
can discuss it a little bit further if possible.
Great. Well, let's see. Is there any other things you would like to cover before we talk again when I come to Madrid area to talk to you?
I mean, no, not really. I mean, obviously, I'm doing the course, so I probably going to have some questions in the future.
Yeah, and so Ignacio is getting his NABCEP PV System Inspector certification, and everybody else should get that too.
I agree with that because I've been working in this sector for a lot of time, and not many people will have that kind of certification. I mean, many people will have, but not all of them. And I would like to people to ask, if you are sending someone to do a technical due diligence to a solar PV plant, are they certified? So if they are not, are they going to be 100% reliable? So even though I'm quite confident with the inspections I performed so far, I thought it was a very good idea to compare with my current methodologies and learn a little bit more and also be certified.
Great. Well, thank you so much, Ignacio Carellan, and that is Carellan. We're going to put all that information in the show notes, along with the website, inverteradvisor.com. And any last words?
Thank you very much for this discussion. It was very interesting to me, and I hope I can make the most of the course I'm learning from you.
All right. Thank you so much, Ignacio. And thanks for listening to Sean White's Solar and Energy Storage Podcast, where you can get yourself the NABCEP PV System Inspector Certification Exam. Anybody could get that certification. All they have to do is study, take my class, and you will be ready. You will be certified, NABCEP certified, PV System Inspector, or any other kind of NABCEP certification that you would want. And now it's time for Ignacio to go to bed because he's in Spain, and it's time for me to go sailing. I'm going sailing with Bill Brooks, another engineer, and a couple of 10-year-olds. Have a great day.